So in this question we have two blocks. One block is M1 and other block is M2. This is our M2. There is a friction between M1 and M2 surfaces and the coefficient of friction is mu. These both blocks is kept on a frictionless table, so mu between these two surfaces is 0. Now we were asked in this question that I can apply suppose in the first part it is asked that I apply a force on M1. Now what maximum force that I can apply on M1 such that both blocks move together. So for solving this question, let me draw the free body diagram. So this is our M1, this is our M1, and the forces, suppose this is capital F. So the external force on this M1 is capital F. This is our that I apply. Now as there is a coefficient of friction between both blocks, that is mu, so as M1 will move in the forward direction relative to M2, so M2 will provide it a frictional force in the backward direction, so this is small f. Now let me draw the free body diagram of M2. This is M2. Now M2 will, as M2 has provided the frictional force to M1 in the backward direction, so according to the Newton law, the frictional force will act on M2, that is small f. Now let me write the equations of motion for M1 and M2. Let me now write the Cartesian system. Firstly, the forward direction, it is positive, it is negative, it is positive, and it is negative. So if I write, then capital F minus small f will be m times acceleration, Newton's second law, and suppose the acceleration of m1 is x1 double dot, so this is m1 x1 double dot. Now suppose, let me write the equations of motion for m2, and this is f equals to m2 x2 double dot. So these are equations of motion. Now let me write the constraints that were told to me in the question. So these two are equations of motion. Now in the equation it is being told that these both blocks should move together. It means that x1 double dot, this is constraint equation, should be equal to x2 double dot. This is one thing, and other thing that is told in the question that we have to find the maximum horizontal force. We have to find the maximum horizontal force, and we know that frictional force is less than the coefficient times the normal reaction. And in this question, as the maximum horizontal force that we have asked is maximum, so friction force will be maximum, so Fs will be maximum, and it will be equal to mu Sn. So these are four equations given to me in this question. What are unknowns? F is unknown, capital F is unknown, x1 is unknown, x2 is unknown. In the question, I have asked to find the value of f in terms of m1, m2 and mu s. So I have to eliminate all the variables. So let me do how to do this. So firstly, what will I do is I will put the value of f in the small f in the equation. So capital F minus mu Sn equals to m1 x1 double dot, and then mu Sn equals to this is m2 x2 double dot. Let me write here that n here is m1 times z. This is our m1 n, and this now this n1 is known because m1 and g is known. Now only thing remain is x1 and x2. So it is that x1 and x2 are equal. So let me find the value of x1 from above, into n equals to x1 double dot, and in the next uh, I should write mu as n equals to m upon m2 equals to x2 double dot. So this is equation A and this is equation B. From this constraint, I should write as f upon m1 minus mu s n upon m1 equals to mu s n upon m2. Now let me find the value of f as m1 multiplied by mu s n upon m1 uh, plus mu s n upon m2. If I put the values of n, then I will got it as what I will got. You can find it will be m1 times mu s, that n1 is m1g, so it will be g plus mu s. This will be m1 m1, this will be g upon m2. So this is our answer. Thank you.